we will be seeing an arrangement to verify Ohm's law. Before starting with that, let me ask any one of you to explain what all are we observing over here on the table.
This is battery, this is meter, this is voltmeter, rheostat, resistance, key.
Here we observe that the positive of the battery is connected to the positive of the ammeter. The negative of the ammeter is connected to the positive of the voltmeter. We have the rheostat. Rheostat has got 3 points where the connections can be made. There are 2 points that are observed in the down, and there is 1 point that is observed which is placed over here. If we connect in this arrangement, we see that we have taken a point which is upwards and a point that is down. That has been connected. Why have we connected these 2 points? If we connect a point which is down and a point which is upwards, we are able to have a variable resistance. If we connect both the points which are down, the rheostat will have the fixed resistance. Is it clear? Here, then there is no fixed rule as to the resistance point should be connected to a positive terminal or a negative terminal. Therefore, for our ease, we have connected negative of the voltmeter to the rheostat. Then it is rheostat is connected to the key and key is connected to the battery to complete the circuit. But the verification of Ohm's law tells us about the value of resistance. So the value of resistance is this. This is the resistance that has been offered in the circuit. The resistance is always connected parallel to the voltmeter, be it a series circuit or a parallel circuit. So we have taken the voltmeter and we have connected it parallel to the resistance. How do we calculate the value of this resistance? To calculate the value of the resistance, let me first switch on the circuit. The circuit is complete, the battery is being switched on. Then I will have a variable resistance which I can shift using a rheostat. We observe the deflection in the ammeter and the voltmeter. Here, is it observed? Now, I will just shift the resistance a little bit. And the value in the ammeter and voltmeter is noted down. Again, the resistance is shifted and the value in ammeter and voltmeter is further noted down. When we have a proper table of the values of the ammeter and voltmeter, we observe that the values in the ammeter and the voltmeter changes in proportion with each other. That means the difference or increase in the value of ammeter will be equal to the difference of increase in the value of the voltmeter. Therefore, we will get a set values of say approximately we take 5 or 7 values, and when we plot these values on a graph, the x-axis is taken as the value of the current which is offered in the ammeter and observed in the ammeter, and the value of the voltage that is being observed in the voltmeter is taken on the y-axis. When we plot these values, then we observe that the values actually coincide on a straight line. Therefore, we can say that the difference of increase in the voltage and that of the current is proportional to each other. And this proportionality is actually the resistance offered by the material. Therefore, V upon I will be equal to the resistance. The reason to take current on the x-axis and voltage on the y-axis is because the gradient or the slope of this line will tell us the value of the resistance that is offered by the material. So this value is the value of the resistance. Therefore, using this arrangement, we can calculate the value of the resistance that is present in the circuit. If I increase this line in the opposite direction, we observe that again it is further proved that when the current is decreasing, the voltage is also decreasing by the same proportion. Therefore, this arrangement proves and verifies Ohm's law, which states that V is proportional to I and the constant of proportionality is the resistance of the material.